Welcome everyone to this BIM Africa session on digital twins and the concept of digital twinning. So this panel discussion is essentially to help us gain better understanding about this technology as it relates to building information modeling and how BIM practitioners and AECO professionals can leverage and make the best of the technology. So without much ado, we're going to introduce ourselves. So I am Kehinde Adeyemi. I'm a practicing BIM professional. I'm a civil and structural engineer, and I'm also a director at BIM Africa. Also a part of the team putting together the BIM Africa event. So who goes next? Dr. Z?
Okay, since you insist. Well, I'm Zulfikar Adamu, and my day job is being an associate professor of strategic IT in construction at London South Bank University. But like yourself, I'm also I'm a strategic advisor to the BIM Africa consortium, and I'm a BIM enthusiast, of course, and I'm glad to be here. I'm a practicing architect originally. I trained as an architect, but I moved more towards engineering and computing and all those sort of things. So that's me.
Great, thank you for being here.
Machiel, I'm the technical manager at Moderna AEC, and we do typically BIM implementation, BIM strategy, almost anything BIM related, software development and things like that. So I was actually trained as a architect as well, got a degree in it, and now just moved over into kind of BIM spaces and implementations.
Great.
Yeah, that's great. I think. Hi, everyone. My name is Selvan Murugan, and I'm a digital practice leader at Zutari. By qualification, I am an automation specialist. So a little bit about Zutari. It is the largest engineering and advisory company in Africa, and my daily responsibilities are basically to drive digital processes in our projects, as well as understand and drive the continuous digital transformation of Zutari. So I'm very passionate, as with many of the panel members, about digital twins, and also eager to see this technology take off once the enabling technologies have matured. And yeah, thank you for the opportunity to contribute to this discussion.
Thank you, Selvan.
My name is Richard Matchett. I spend my life talking about digital. I also work for Zutari. I work with Selvan. And as he said, our daily reality is looking at how the new opportunities available through technology, through programming, change the way our world is shaped and made. I have a particular passion for digital twins. So this really is my heart's topic. Apart from motorcycling and various other technological things, digital twins are really occupying most of my conscious thought at the moment. I'm also studying about it. And so I'm really looking forward to hearing, I think, what our collective insights are and sharing that with the continent. Thank you so much.
Great, thank you. And so there we go. So we have a better idea of who our panelists are now. And so without much ado, we go straight to start with the big question. So what is digital twins? What exactly is digital twinning with respect to our industry? What is it? So I'm curious, I want to know what digital twin is. So who is going first?
So I think it's definitely something digital. And I think as we talk, we're going to tease our audience a little bit, aren't we? So it's definitely something digital. It's definitely a twin, which means that there must be two of whatever we're talking about. And because it's digital, it needs to be about information. It needs to be about how our world is understood and how we understand the way to change our world through digital means. So in a nutshell, something that is mirrored by something that is virtual, with information that describes the two, and various very clever processes that enable the data to help us understand reality.
I'd also like to add it's a visual aspect as well. When you talk about information, it's not just a flat lines of code or just those kind of representation. There's a visual aspect to the digital twin.
Okay. Dr. Z?
Yes, I think those are very good definitions, but I think like not something that you have a single definition for. It means many things to many people, and I think it's important to understand that the concept did not even start from the built environment. So where we understand digital twin might be slightly different from how some other industries might look at it, but there will be a lot of similarities. But as the others have said, visualization is very important. Obviously, digital, which means information, or more importantly, data flow, it's very, very crucial. And I think if you look at the origins of digital twin, I think the one key thing also about it being digital and visual is that there's a sort of bidirectional flow of information and data, which means from the virtual, you can technically control the physical, and from physical, you can be able to manipulate the virtual, maybe to look at what if scenarios and the rest of it, So the virtual helps you to understand the physical, and the physical gives you an opportunity to fine tune and, improve on the virtual so that, for example, future projects or for the operational phase of that asset, you can understand that building better and can help inform you whether you want to save energy or optimize spaces and the rest of that. So yeah, that's not much to add to what they've said already, really.
Great, thank you. Selvan, you want to add something?
Yeah, so I agree with with all of the panelists so far with the definitions of the twins. What I wanted to add is that I think it's sort of important to understand that there's no actual definition of the twin, so it's more a concept at the moment. So there's no standards, there's no regulations, there's no guidelines as to how to develop a digital twin, let alone define what it is. I think we all agree that it is there's a physical component, there's a virtual component, and there's data transfer in between those two aspects. But it's important, I think, as we go through the discussions to understand how we actually go about doing this in the built environment, and speaking specifically from a contractual and design perspective.
Great, thank you, Selvan. Thank you so much. Okay, so now we are beginning to have an idea of what we're talking about, but I want us to pair this, to put digital twinning in context with building information modeling. How do these two come together? Okay, so I don't understand what the concept of a twin is now, and of course, so I have digital on the one hand, and then I have the twin on the other hand, and so these are coming together. But then with respect to building information modeling, how does this pair up together? How does this make sense? Can we make sense of this?
So one of the interesting aspects of BIM and building information modeling is that it is almost always implemented at the design stage of a project. So building information modeling pretty much the majority of the time is a design modeling process where a three-dimensional design of a certain asset is done in such a way that the components of that design are linked to data. A digital twin, on the other hand, is intended to assist in the life cycle operation of that same asset. And so if you take the continuum of any asset's life from design through construction into operations, BIM, when it reaches maturity and is continued into that asset's life cycle, naturally has an opportunity to become a twin. But just like, you can create a doll that looks like a human, but until it starts breathing, it's not really a human being. That BIM model needs to come to life during the operational phase with live data. And as Dr. Z was saying, there's a flow and transfer of information between physical and virtual. And that is what makes a BIM model come to life as a digital twin and start influencing the way that reality behaves based on what happens in the virtual world.
Yeah, I think that's a very good way of putting it. I mean, add to that, I would say that one of the things that worries me, in the early days of digital twinning, is that some people would like to think, oh, it's the next thing, is the new BIM. It's not. BIM will always be there. Richard has said, BIM is mostly used in the capital phase of most projects, the design and construction. But you think about the chief beneficiary of digital twins will be owners, facilities managers, and users. After the asset has been built, how do you now maintain this facility? How do you optimize it? How do you know it's fit for purpose? How do you reconfigure it? And I think that we are fortunate that we live in an era where we're seeing this sort of seismic change. Because I think that people we take things for granted with the digital technology taking over the world in many ways, Internet of Things. But many years down the line, we were like those who witnessed the first cars being witnessed when people started moving from horses and started driving cars. The way the industry's changed, we are in a state of flux where we're seeing a lot of changes. And I think digital twins represents sort of an apex of what we've been doing so far. I mean, there'll be more sophisticated things to come in future. But for now, if you think about our journey as in the BIM world, I think digital twins kind of gives us a kind of end goal to aim for. It's not a replacement for BIM. It's one of the end games, one of the end products of working through the BIM process, because you can't have a digital twin if you haven't, for example, procured the building through digital processes with digital models and the rest of it. It'll be very difficult. I mean, you could, but it will be very difficult. It will not be efficient.
Yeah, and I agree completely with that process. For me, always BIM is the foundation for a digital twin. If your BIM model is not compliant with the information requirements, the digital twin will be lost at the end of the day. Or that information flow will be lacking in so many areas, it wouldn't make sense. So for always been a case where trying to produce a digital twin is to make sure that your BIM models is modeled accurately and your assets that you want to attain to the digital twin lives within those environments. Yeah, so I think that's my summary of it as well.
Great. Thank you. Okay, so let's talk a little about the attributes of the digital twin technology. Of course, there has to be the element of connectivity, and then, of course, digital to start with, modularity, smartness, homogeneity. So can we talk a little about some of these technology attributes? Selvan, you want to give this a shot?
Yeah, I'll take that bullet as well. I think some of the many of the technologies involved in the digital twin are available at the moment, and I think with the previous question, BIM definitely does produce a version of geometric information that goes into the twin, and I think when we look at digital twins from a holistic perspective, and I think then I start realizing that we need highly accurate 3D modeling to levels which are more realistic, and that correctly defines the twin from a visual perspective. Other technologies would, if I think off the top of my head, would be cloud-based hosting platforms for the hosting of 3D models and realistic visualizations. I think it's really important to consider from the a point for the audience to consider is that if we try to develop or model a smart city, that data runs into petabytes, and it's not something that our common design tools can provide at the moment. I know I'm digressing, but some of the other technologies in realizing a digital twin are databases to collect all types of information related to the physical product. We're looking at the IoT platforms to allow for connection of real-time data to the physical twin. And you're looking at other types of data systems such as MIS, those are manufacturing information systems, MES systems, historians, which collect historical information. And another large part of The technology stream is data science platforms, which allow us to basically develop machine learning and AI, as well as predictive analytics. So a twin basically relies on all of those technologies coming together to solve a business problem.
Great, great.
I think just to add on to what Selvan has said, because there are so many different components, one of the key parts of a digital twin is the systems architecture of how these things fit together. I think many people think that a digital twin can be achieved by buying a piece of software. Now that is not true for BIM, and it is even less true for a digital twin. You know, the number of different platforms, systems, integrations, scripts, services is immense. And depending on the outcome that you want to get from that digital twin, there are also an additional layer of services. So the queries that need to be done, the dashboarding about the information, the user interfaces to access the combination of geometric and numerical data. So I think that is one of the biggest reasons why, in my mind, a true digital twin is still a unicorn. I think in the manufacturing space, there have been amazing breakthroughs. My favorite example of a digital twin is a Boeing 777. That airplane flies itself, understands itself, adjusts its own behavior, and informs its occupants and the captain of how it is performing in real time. To me, that is a good digital twin. We don't design airplanes. We're architects, engineers, QSs. We are concerned with designing buildings. And I think that when it comes to a building, this is still a very new concept, and there may be a handful of examples worldwide that truly work to the same level of sophistication as an airplane would.
Okay. I guess it's my turn to
Yeah. It's yours.
I'm not too sure I remember what the original question was, because there was quite a lot that's gone into the answers given so far. But I'll say that, to add something to this, I'll say, yeah, if you could go that would be helpful. If you go through
Okay,
that.
all right. So we're talking about the technologies that go into digital twinning. And also especially the attributes of these technologies. So what attributes, what technologies, for example, connectivity, data gathering, sensors, simulation, analytics, you know, AI and all that. Yeah.
Okay. I think that first of all, connectivity will rely on, you know, the broadband technology, the internet technology. You need that. Many people take these things for granted, but without even broadband or internet technology, even BIM itself will be difficult. I mean, how could you use a common data environment without a web-based system? It would be very difficult. So you can imagine for digital twin how important it is for these to be almost constantly live, because most common data environments are used on, you know, as the need arises. But a digital twin, for it to be able to report, for example, the Boeing that he talked about earlier, if you want to have a building that behaves like that tells you how it's performing in real time, you must have constant connectivity. So this is something that people have to think about. So that whereas there are a lot of enthusiasts out there who want to jump, oh, we need to have a digital twin. Have you thought about some people can't even afford data to use on their phone, you know, just to communicate and talk, and you want to have a building that constantly reports data every microsecond and tells you how many times the kilowatt of energy has been lost through the window. I mean, it's quite a lot. I mean, we can get there, but people need to understand that. I mean, the Internet of Things technology itself, it's very important. We need to have that embedded systems and all that. Again, it is not going to be about procuring these technologies and installing them, the maintenance, because the whole point of digital twin is to keep improving the product, which is the physical product. Digital twins do not exist to glorify the twin, digital twin. Digital twin is to help the real asset actually, but you need to have a virtual model so you can play around with it. Like any model, it's an abstraction of reality, isn't it? So we need to have the technologies that would allow us to be able to maintain the buildings, but also the technologies themselves have to be maintained. do we have the capacity to maintain these things? IoT-based systems. It's something we need to think about. But also, I think in the context of purpose, it's very important that the digital twin is the technology behind that is aimed towards solving problems or making life better. It's not just there. It's not a solution looking for a problem. It must be something that meets a certain purpose. And I think in this regard, maybe what we have in the UK called the Gemini principles. It's something that can help us address that. First of all, I think the first purpose is to be public good. There must be a reason for that twin to exist. It delivers some good to the general public or to the owner. It must create value. It must be able to give you insights. So when you think about all these technologies, how much public good comes out of it, how much value is created from that. It's not something you do as a trophy sort of thing to show off. I mean, many AEC firms like to show off, to brag, we've done this, we've done that, do some nice billboards. But if at the end of the day, you're not delivering value to the end users or the client, or you're not producing insight to the FM people, then it's going to be a problem. One other aspect of technology will be security, because once you start to put things digitally, or once you start to put things on the web, through the internet, security is a big deal, because someone with some terrible intentions can take over a building and start to manipulate things. I know of a case where there were some hackers who hacked a power station, I think in Ukraine. I don't know where they came from. Some said it was Russian, some said it was whatever, but I don't know. But they took over a power station and shut down, I think, the capital or something like that for some time. Fortunately, they still had the analog control, so they could go over and override the system, you see. So these are some of the issues that we have to think about when we start to go towards these sort of things, because security will be a big deal. That's around somewhere now. The NHS in England has fallen into that trap, and I think some cities in the US have also been hacked into, some municipalities, and they had to pay up. When someone takes over your services, you can't do anything. Imagine if an airport's digital twin is taken over by some nasty people. You know what I mean? So these are things that it's not just about technology, adopting it and implementing it. We think about so many things that traditionally we weren't used to worrying about. So, for example, security. It was only the built environment, we say, is not very digitized. It was very late into the game of digitization, one of the least digitized industries. But those like the banking and the retail, they've had to deal with security all these years. They know about hacking, about espionage and all those sort of things. We also have to get into that world of understanding that once you go digital, you're not safe. And the only way you're safe in this world today from being hacked is go offline. Once you're online, everything is hackable. Some things I just want to add to what my colleagues have said. I mean, there are a few more aspects of the Gemini principles, but I just mentioned a few that I thought were very relevant to when you talk about the technology behind it. I think one other thing that I'll point out will be evolution. That technology has to also allow you to be able to, part of the Gemini principle, to be able to evolve. You don't want something that, okay, it's good, it's fit for purpose today, but 10 years down the line, it's become outdated. To replace it, become expensive. It can't adapt. It doesn't lend itself to adaptability because times are changing. You know what I mean? So that's something very, very important.
Thank you, Dr. Z. Okay, so let's get a little bit down into digital twinning. So say I'm a practicing organization, a firm, maybe an AEC firm, and we want to embark on a digital twin project for, say, one of our clients. Let's talk a little about the creation process of a digital twin. The kinds of data and information that are derivable from a digital twin, and then the use cases, okay, the use cases for the built industry. So let's talk a little about this. How do we start off the process? How do we create one? How do we initiate the process of creating a digital twin? And what kinds of information, are derivable from this twin? And how are they really useful, to advancing the built industry?
I think I'll start on this one because it also ties in to a part on what was the previous question. And Dr. Z and Richard kind of made a good point about it, is when you start talking about a digital twin, you need to look at the outcome or the purpose of the digital twin. The moment you say you want a digital twin, is everything is, kind of a go. So it's when you start talking about it, is always look at what you want to manage in your digital twin and build towards that direction. And this is kind of where the ISO standards also forms part of it. is you want to look at, let's say I want to do HVAC control systems. I want to track that. You need to make sure your whole production line from the BIM starting point is geared towards the modeling, the content, the information, everything towards that end. It's no point in saying we want to go digital twin and we want to track walls. What's the purpose of having, that element or that information? And then, yeah, at the end of it, I always believe anything is doable. When you look at digital twins, you need to find out where the end line is. My favorite example is basically, or my simplest form of digital twin is your Fitbit watch. That for me has always been a digital twin of your body health. So what I want to track, I want to track that, jogging speed, running, or whatever the case might be. But your watch is also connected to the internet. So looking at a digital twin, you can start tracking people's movement through buildings if you want to go that route through down the line. I'll leave the rest for the other guys.
Thanks, Machiel.
I would say that, let me come in now and say, maybe to add into that, it's very important, like he said, what's the purpose? We've all mentioned that. We don't track what's not trackable, but also because when you go digital, you start to collect data, through IoT sensors and the rest of that. You're talking about massive amounts of data being collected in real time. You can't just decide, well, this twin will operate on certain days and certain times. It's something that's going to be operating constantly. So in this regard, I think one useful thing for practitioners is to be careful what they try to twin. You know what I mean? Because you could have a digital twin of a door if you need to know whether that door is open or closed, whether that door is operating, how much heat is flowing through the door, whatever, traffic that flows in. But how do you need to see that door is a different thing. My colleague who just spoke talked about tracking people. Do we need to see them physically like human beings standing with hair flowing? That's a lot of graphics and data that's going to be chewed up. You know what I mean? You might want to use agent-based models. For example, a dot can represent a person. If you want to see the details, you can, zoom in, double click and get the details of that person. But you don't want to start representing some final details when it's not necessary. You know what I mean? If you look at the aerospace or mechanical engineering industry, when they do their twinning, they use a lot of spreadsheet-based approach because it's not always they need to see the physical aspect of, say, an engine running, unless they want to look at fractures and maybe, some areas where some faults might occur. A lot of times when we talk about vibration or rotation, they're looking at, time series data in a graph. And I think the built environment can learn from that. We already have experience using building energy modeling system, building management systems, you know what I mean? Where we already have things that can track transient data. And a lot of that can be fixed into real-time purpose that can serve digital tuning purposes so that you don't end up overproducing information, because there's something called, you can have too much information. In fact, there's something called information bias. You know what I mean? You can end up with so much information that it's not even useful. You get clogged up with, you don't even know how to extract value because you are collecting too much. You need to know how to be very careful about what you're tracking, what you are collecting. And it all depends on the nature of the building, the purpose of that building, the end users, and what they want to use it for. But having said that, I think it's also important to point out that because, like, who was it who said it's like a unicorn? It's still something that is work in progress. I barely know of any proper digital twin building that exists as of today. So, but again, it's an investment you have to make. Sometimes you have to think about or imagine some future need and make the investment today. You might not need that data now, it might not be useful, but sometime down the line it might be useful. It happens also with BIM. A lot of times we put a lot of data information into object-oriented models. We don't really necessarily know how to use them, but somewhere down the line, some maintenance person or manufacturing person might find a use for that information. But then again, you don't want to overdo it. So there's a fine line to be drawn between what's useful today and what might be useful tomorrow.
Yeah, Dr. Z, before we move on to another contribution, you touched on digital twin being a unicorn just now, but I'd like you to throw some light on this from the angle or the perspective of the Gartner hype cycle. I know there's a quote from Gartner 2018 that says that with an estimated 21 billion connected sensors and endpoints by 2020, which we are in right now, digital twins will exist for billions of things in the near future. That's a quote from 2018 by Gartner. So now, looking at the Gartner hype cycle and the development of technologies, especially the digital twin, please, can you share some insights on this?
Well, on the same token, when they say there's going to be billions of devices or objects that have digital twin, I mean, your smart car is a digital twin. Your basic aeroplane of today is a digital twin. Your fridge, if it's a modern fridge, is a digital twin. They have someone is looking at the data that comes out of that fridge. But you have to understand that in the built environment, we traditionally as the second least digitized industry after agriculture and hunting. So it doesn't quite apply to us. All these billions of devices are talking about. Yes, I'm saying there are buildings there that can be classified as digital twins, but by far, we're not really anywhere close to what other industries are already doing. So on the Gartner hype cycle, I would say we're probably at the peak of inflated expectations. I think a lot of organizations who go into digital twin will fall flat before we hit the plateau of productivity on the Gartner hype cycle. And it's not about the built environment. Every industry goes through this hype cycle thing, because people who expect digital twins to solve all their problems. You think there's the next thing after the next best thing after saying sliced bread or whatever. It's only later that some organization realize that, you know what, this is not really something that has given us value for money. If I was an FM company, I'll be very excited about digital twin. I'll be more excited about digital twin even than, say, an architectural firm, because most architectural firms will design, they will construct, and they walk away. Except in places like the UK, where, for example, due to the soft landing principles, our designers are meant to hang around and observe that building for the 3-year post-occupancy stage, where they learn from their mistakes. And that's where they can also benefit from a digital twin, and they can also participate in maintenance, because the best person to maintain a building actually is the guy who designed it and constructed it. But in a built environment, we have the history of just designing, constructing, and walking away. A group of people who have absolutely no idea why that building was designed will come over as FM people and start to maintain it. I'm not saying they're not qualified to be FM, but they don't really know that design or that building the way the designer and the contractor know it. So with things like soft landing principle, the designers and the contractors who build and design and build that thing will be engaged for much longer. And that will open new job opportunities. All of a sudden, a firm that was just into design finds itself doing things like maintenance and adaptations, especially in the world that we live in now, where, for example, we have COVID going around, devastating communities. We have a lot of assets that are being wasted in city centers because everyone's working from home. So what do you do with these spaces? We need to start to think about flexible and adaptable buildings that can cope with changing times. It might not be COVID, it might be some other circumstance. I think even the COVID thing has taught us a lesson that remote working is reality, because all of a sudden we now find ourselves in the post-COVID world where people start to question, why are we paying this massive amount of rent when people have done the same thing we were doing it during the COVID days? So this is where the buildings of the future will need to be more adaptable. And that's where you need the original designers, not a bunch of people who just come and knock down walls and say, don't worry, we'll give you new spaces. No, you need a building that can evolve, that can change places, flexible walls. I think we're going to see a lot of, and that's where the Internet of Things will also help, because with digital twins, you can even tell your commercial buildings what space is less optimized. Why do you have this corridor this wide? Why this bathroom this narrow or whatever? Am I getting money from this? Because you can tell from the way people use that space whether or not it is value for money. Sometimes we do things because it's rule of thumb. It's what the standards say. The standards say you should have one bathroom for every 100 people. But really, in a particular building, if you find out that you need more bathrooms or you need less bathrooms because you're getting real-time data, then you need to be able to adjust that, not just follow some rule of thumb or some prescriptive data. I think we're going to move into more performance-based approach to buildings, which you see happening in North America, for example, in fire safety. They move towards performance, not just prescribe, and hope that it will solve the problem. Sorry, I think I went a bit too long with that.
Thank you, Doctor. Thank you. Selvan, you want to add something? Or I move on?
Yeah, I think I can quickly add something on the Gartner hype cycle. For me, the very fact that Gartner has it on the hype cycle means that it is definitely a recognized technology. And there's an incredible focus on the twins in the market. And there's extensive research that's being done in that field. And I think I had a look at some of the research, and it seemed that in 2018, the digital twin was at the peak of inflated expectations. 2019, there was no movement. And in 2020, the digital twin technology moved into the IoT hype cycle. And it seems as though it was sliding into the trough. So that's very interesting. What normally happens in that space is that producers of technology start moving out, and we see technology organizations start to fail in this regard. But what we also see is that this thins out the organizations who are really competent from creating twins or for creating twins, and ideally we should see the trend going upwards after that trough. So I think from a gardener perspective, it's good that the technology is what we call dropping, and it's certainly good for the built environment.
Thank you, Selvan. Machiel, I'll start with you on this one. Digital twinning concepts application to cities, people, and processes. Now, we understand that obviously digital twin as a technology itself is more like, having a second version that is true to the first version in all sense of the word. So that means that there might even be some expansion to people and how people work, and even processes like manufacturing processes and all that. Then also talking about application to cities, we talk about smart cities all the time, but we know that buildings, roads, infrastructures, all these come together to make up a city. So from the perspective of an expanded concept and possibility, how do we see digital twins in the affairs of, in respect to this kind of application?
Oh, it's a loaded question there.
Yeah.
So for me, looking at kind of the digital twin or the smart cities of the future, for me, that feels like technology 50 years away. I feel like we're still struggling with the reality of just getting a building into a digital twin environment, let alone trying to build a whole city that is smart, that is reactive, that is intelligent. I know Sweden did kind of call it a first iteration of a smart traffic simulation where they could navigate people from their homes to their businesses and optimize traffic through that process. Again, that is doable, but the amount of cameras, the amount of AI and machine learning you need behind a system like that, and the amount of data transfer, I personally don't think we're at a scale to transfer that amount of data, let alone keep it active, like Dr. Z said, on a millisecond basis for machines to continuously do that. So yeah, for me, it's a future thing.
Okay.
One of the interesting things about our world is it's big, and things operate at different scales. So if we're looking at travel, for example, if you're walking by foot, 2 kilometers might be a long way to walk. If you're in a car, maybe 200 kilometers. If you're in a plane, maybe 2,000 kilometers. It's the same with how we represent data. The scale of the data and the platform that we use to represent and manage that data is going to be with respect to what it is that we're looking at. So if we're looking at a countrywide network of a power grid, for example, it's most likely that is going to be represented graphically and in terms of data on a GIS platform, for example. Whereas if we're looking at a power generation plant, we may be using a BIM system as a basis for the geometric and data linking. And if we're looking at a turbine, we might be looking at a single model-based viewer. And so I think coming back to the idea of architecture, with all of these different ideas of scale, there's a lot of research being put in at the moment with the crossover and linking between BIM and GIS. And I think that the product of that research is going to be a greater ability to switch between those different levels of scale. That when the question that you're trying to answer by using a twin at a city level is related to the power grid, for example, the place you're going to go and look is at a GIS level. Whereas if you're looking at the characteristics of something within a turbine hall, for example, at a generation, then you'll be looking at a BIM scale. So as we start seeing cities take the decision to start combining models into a system of systems, as they start looking at how they're wanting to harness the capabilities and potential of twins into smart cities or systems of twins, that architecture is going to be critical of how the various different building blocks fit together. And I think when one starts embarking on designing something like that, a fundamental question is, why are you doing it? What is the advantage of using that twin to solve a complex problem that couldn't be solved some other way? And then the design and the architecture should flow out of that business process approach into creating something that is going to add benefit to the decision makers.
Okay, great. So I have a very quick question, just to make this a little bit practical. So let's say that I'm able to digitally simulate the construction of a road process. The construction of a road, for example, the process into construction of a road. I design it, I construct it, and I'm able to simulate, say, cars or trucks going past that over that road, and then I'm able to extract some information with respect to, let's say, maybe how long it will take for the road to fail, you know, and maybe where we might have to start dealing with potholes, the effect of flooding on that road or on that bridge or something like that. So if I'm able to digitally simulate that, am I digital twinning already?
So fundamentally, the concept of a digital twin, and Dr. Z started off his comments with that, is it's a two-directional thing. Infrastructure is different to a machine. So yes, we can gather information, we can simulate information, we can draw it from the real world into the virtual. We can then process that gathered information to derive most likely outcomes. What needs to happen to make something change in the real world is we've got to appoint a contractor with machines to go and make changes into the real world. And so there are agencies or agents that need to come into that closed loop of a digital twin to actually do the theoretical term is actuating. The actuation of decisions that come out of the analytics need to be then done through human beings. So yes, I would say, Kehinde, the act of simulation, gathering, and then representing decision-making material is half of the truth. It becomes a twin when those two halves of the twin interact. And in the case of most infrastructure types that are not automated, there are human beings involved in that cycle. And so we talk about human in the loop systems. But yes, that is something that has been, incidentally, the pavement management systems have been in development for a few decades. And in that sense, ironically, the roads are ahead of the buildings, which I find quite interesting.
Great. Dr. Z, you want to touch on this a little?
Okay, yeah, I think I'll say that because you mentioned simulation, and I think one has to be careful about using that term simulation in the context of digital twin. Not that you can't simulate, but first of all, one of the reasons you might want to use a digital twin, or some of the reasons you want to use a digital twin, if you can simplify it, will be one, either forensically or for prediction purposes. Forensically means you want to be able to use that twin as a base of investigating what happened, because in the real building, when something happens, it's happened. But with a model, you can tweak things and kind of do some reverse engineering, which you couldn't easily do in a physical building. But also with digital twin, you can predict things ahead of that building. What will happen if you keep getting this amount of people coming in, using this amount of energy and using this number of whatever, you know, resources in the building, water, electricity, and the rest of that. So why would you want to simulate? If your purpose is to represent that building as it is, then you're only going to be able to simulate if you want to predict, if you want to be able to see what happened. Because a model, because sometimes people confuse modeling with simulation and they use them interchangeably. It's not, I don't think it's quite the same. A model is an abstraction of reality. When that model is in use, then it becomes a simulation. You know what I mean? So when you want to simulate using digital twins, you're probably going to be doing things for prediction purposes, for maintenance or whatever. It's also possible to simulate things in the reverse engineering for forensic purposes. But a lot of times you want to be able to use the digital twin. I think many people use it just for a lot of day-to-day management and understanding and taking precaution without necessarily simulating ahead of time. Because why would you do something forensically, or if something went wrong, or something happened that was fantastic? Maybe you had some best practice of how energy was managed in a particular building. You want to be able to go back in time and look at the data, the way it worked, and the rest of that. So I don't know why I'm dragging on this, but I just feel that we should be careful not to confuse digital twinning with the kind of way we simulate things in, say, VR or some other kind of finite element simulation and the rest of that. This is real. Of course, you have these two things coupled together, and what you do to one can affect the other. So this is just what I want to add to that.
Great. Thank you, Doctor. Anyone wants to give this a shot? Anyone else?
I wanted to mention a really good case study that I read, Doctor. I'm sure you've seen it as well, where they tested the concept of a digital twin on a wind turbine. And the benefit that they derived out of it was to use simulation to predict what it should look like and run those different scenarios, and then using telemetry to measure the actual. And because of the simulated likely future cases, they were able to then almost pre-calibrate the sensors or the trigger events that were being looked out for. And I think that therein lies one of the useful parts of the simulation, to say these are the likely future scenarios that need to be triggered through to the operator to take an intervention, and also through that to use the process of prediction and calibration to then continue to fine-tune the predictive maintenance for a facility. Obviously, the more variables and degrees of freedom in a certain situation, the more complex that likelihood calculation becomes. So it's in my mind, it's an interesting quandary. To what extent is the digital twin a reactive system, and to what extent is it a predictive system? Some authors are talking about the twin also becoming a three-dimensional graphic historian, to record information and use that as a basis for learning, whereas other authors are talking about it being more about prediction, more about avoiding the avoidable, by having a better holistic picture of how various different variables fit together. Honestly, I think time's going to tell which of those scenarios ends up, being more prevalent, and that's going to be one of those, let's see what works. It's very early days still.
Yeah, thank you. I think that also explains why people say, the whole concept of digital twin, at least from the built environment perspective, is still largely theoretical. We're still playing around with concepts. We think, we hope, we believe. We don't really have real life case studies of buildings in use that we can say, okay, this is how they've used it, or this is how we should use it. But that's why I think also we need to be careful not to let it not be a solution looking for a problem. We should let everyday problems dictate how you use digital twins. We can look at our problems. Let's say look at Africa as a context, as a narrow, where we're still developing. We can look at how digital twinning can help us overcome some of our problems. If I'm being honest, I think digital twinning probably has more chance of success in the infrastructure world, quicker chance of success than maybe in the built environment, because the problems that affect people in Africa will be can easily be touched by digital twins on infrastructure and in smart cities, things like flooding and disease control and stuff like that, than at individual building level, unless you're talking about mass housing or something like that. What's the benefit of having just one twin of a building somewhere and that's it? Okay, it helps the owner of that building, it helps the users of that building, but you want to think about it in the context of smart cities where it solves problems on a wider scale. In fact, some data cannot make sense unless you look at it in context. If you have one building performing in a particular way, you might not be able to contextualize it unless you have similar buildings to compare it with. It's interesting. We have it's an empty canvas. We can write our story, but we need to be careful what kind of colors or text we use to write that. Let's not just copy other countries and other continents, and because they solve different kinds of problems.
Very true. Very true. Thank you, Dr. Z. So before we move on to Africa, Africa is an entire case entirely. We'll get to talk about Africa in a bit. But just a quick one. We know that building information modeling for BIM to get to where it is today, there were a lot of pilot projects, there were a lot of funding, there were a lot of interest, keen interest. There were a lot of demonstrations with results that had to be done to make a case, a business case for this technology and why it should be adopted. So talking about digital twinning, what possibilities do we think can be derived from piloting? Okay, are we able to identify specific problems as it touches on vertical BIM and horizontal BIM? Are we able to identify this? Are we able to make a case for piloting and probably even scaling, industrializing, and being able to evaluate and get derivable results from that? So piloting with respect to digital twinning, how reasonable is this?
Let me start off on this. I think piloting is definitely an exercise that practitioners in the built environment and every other environment where digital twins are considered needs to happen. But I am very wary that as we go down this route, and we've seen it for ourselves, we are coming up against a skills deficiency. So to try and put this together, even in a POC context, we're looking at advanced skills in 3D modeling, in simulations, in web design, sensoring, instrumentation, automation systems, and particularly database engineering and data science. So even a POC, in my opinion, needs to start off very small. So I think, start off small, and we definitely need to think bigger. I think as my colleagues have mentioned, we need to treat it or we need to look at the problems and then find solutions that digital twins can offer to kick off that process. Just one more point I want to add is that we are caught, I think, in the middle of an incredible digital revolution at the moment, and digital twins are just one of those technologies that are being considered or that's available to us at the moment, which is great. So I think making the right decisions to pilot at different stages in the project's lifecycle is crucial. But yeah, definitely we need to pilot, we need to proof test, we need to experiment with those integrations, experiment with the predictive analytics, and try and make sense of the successes that the twin can provide.
Great. Dr. Z, you are going to touch on that?
Yes, on piloting, I think it's going to be a crucial tool for successful understanding, first and foremost, and then learning and implementation of digital twinning, because even with the BIM process of the BIM journey, I think it was Heathrow Terminal 5 was one of the first buildings that, at least in the UK, was used to pilot some of the things that became level 2 BIM and the rest of that, the way it was designed and procured. So it helps to convince the industry, the stakeholders, about the usefulness of that process or that technology. And I think that choosing the right pilots will also be very helpful. If you were to pilot digital twinning on some low-cost housing somewhere in some remote part of Africa, I don't know what value you might get from that and what people will see as benefit. Because look, people want to use digital twins to solve problems. They want to use digital twins to either make it more profitable, or to reduce cost, or to make buildings safer, or whatever it is. There has to be some end game. So choosing the right kind of pilot project will be very, very important. It's crucial. In fact, I was surprised if if you look at it from national level, because a company can decide to implement digital twin. But if you think about it as something that a national body or some sort will want to back, the way, say, some governments have backed BIM, we definitely need to have pilots. But even at an organizational level, if I was into property development, why would I want to just implement digital twins in all my new estates and high-rise buildings or condominiums when I'm not too sure how much value I can get when I've not learned from my mistakes, you know? Because it's very easy for us in the built environment, and it happens in other industries, to think we know the solution to everybody's problem. We design houses or offices or whatever, we give it to the end users, and you know. But at the end of the day, how they use that building, the way they use that building, might be a little bit different from what we intended. And this is why I think the soft landing principles is very important. And just for clarity, the soft landing basically, from the definition, it means soft landing, like you know, an aeroplane coming from the air. It lands right on the tarmac, so it has to have a soft landing so that it is a smooth transition. That's what it means. Now, in technical terms, it means handover, more or less. Like if you do think about the car industry, you know, or the manufacturing industry, when you buy your new Samsung fridge or smart TV, or you buy your new Toyota car, Toyota is invested in you. They're interested in making sure that that car performs well. They'll make sure they call you every 6 months to come for a free check. You know, make sure that you're using Toyota oil or Toyota filters and whatever, Toyota products, because it's in their best interest for this brand new Toyota car to perform best for you. They don't want you taking their brand new Toyota car to some roadside mechanic guy who doesn't know anything about Toyota and he messes it up. So this is why I think that soft landing would be very crucial in getting digital twin to work, not just in Africa, everywhere else. Because once you don't engage with the stakeholders, you see, soft landing principles, the way it's used in level 2 BIM in the UK, is such that there's a soft landing champions embedded in the design team. The minute you start to specify a door handle or a floor finish that is too expensive to clean or maintain, or they cannot find spare part easily, it tells you, no, we don't want that. Because designers were fond of putting things that fancy, that are very nice, but the end users end up struggling with maintaining that because they didn't factor the cost to the operational stage. So having that operational end game in mind is helpful, so that when we start to make twins successful, we've done it with the right intentions and the right processes in place. So this is why piloting will be very useful. You need to have those pilot projects carefully selected, strategically selected. Perhaps this is where maybe cross-national or inter-regional alliances could work, you know, where rather than have one country piloting is digital twin in a commercial building, let's say a mall, and then another country repeating the same thing. What's the purpose of that if they have similarities? I'd like to see a situation where maybe South Africa might pilot a digital twin of an airport, and maybe in a place like Nigeria, we pilot a digital twin of a factory or mall or something, you know, and then we can share learning and everything, so that we benefit from what they've done, they benefit from what we've done, rather than repeating the same thing again and again and again. There's no point.
Great, thank you, Dr. Z. Now, about operations and maintenance, Richard, I have a question for you. I'd like to, you to share some insights, some more insights on why digital twinning technologies can be valuable for operations and maintenance of assets, I mean, built industry assets. You know, how can we begin to look towards this technology for probably digitizing, you know, and making maintenance and operations processes smarter? What values can clients begin to look forward to deriving by virtue of this technology?
One of the simplest values is having a clearer understanding of what their infrastructure and their plant looks like. So as Doctor was saying, that soft landing process or the handover process is critical. One of the biggest challenges to an operator is knowing exactly how their own plant works and where things are. So having a proper assets information model that is represented graphically, even if it's not a dynamic link yet, if it's just an as-built BIM, just that is a huge advantage to operations and maintenance. Being able to rapidly get information about the as-built specifications, the characteristics of what has been manufactured, that is already a value. Then having information about how that facility is performing assists in understanding where things are breaking more commonly, what the cause and effect cycle might be for certain problematic areas of the facility, and then being able to use that to statistically understand how to improve the system to reduce common mistakes, common issues, common problems. Those are some simple low-hanging fruit. I spoke to a colleague a while ago who was once required to go live on a new hotel. And one of the challenges they had was the safes in the rooms had an operating system that was managed from overseas. And they had a guest that needed to get to the airport in a hurry. And on the day, they weren't able to get the solution on hand quickly enough, and they had to drill the safe open. And it seems like a small trivial problem, but those are the kinds of things that really trip up. I think often when it comes to operations, it's the small things that trip us up. You know, we're ready for the big things, but the accumulation of many small things can really be a headache. So I think, again, it depends on what the twin looks like, what its characteristics are. And it also depends on the foresight of the operator to know about the type of infrastructure they have, and then to run through those scenarios to say, you know, what am I going to encounter? Experience is very important in the planning of that twin solution, knowing what is the twin going to need to do. And I think that's when value can be built in up front, rather than, you know, investing in the hopes that something's going to work nicely. That would not be a wise investment.
Great, thank you, Richard. So on a closing note, I'd like us to, you know, maybe in a minute each, just do a quick analysis. Where are we in Africa? Building information modeling, digital twinning, digital technologies. You know, we are Africans as much as possible, and we have the responsibility of, you know, putting our expertise to, you know, developing our continent. So where are we in Africa? How can we leverage these technologies? How can we make it better? How can we begin to incorporate this into providing solutions, sustainable solutions for the future? So maybe we'll do a round robin, or maybe I'll start with anyone. Machiel, start with you.
Cool. So looking at the future as digital twins, for me, it's still coming back to our foundation level into the BIM world. We need to make sure that our BIM models is compliant or standardized in a process where information could be handed over in the soft landing space, as Dr. Z mentioned. If we don't start at a good foundation, you're going to have call it a mess up when we're trying to create this whole digital twin world that we're aiming for at this point. So I think looking at that as a kind of an Africa as a nation, BIM standards is for me a critical step towards the right direction.
Thank you, Selvan.
Yeah, so thank you. I think from an African perspective, I definitely think that we have a good track record in creating 3D models, as well as in sensoring and automation and IoT solutions on the continent. There's some incredible skills that we have. I think we as a continent have pockets of excellence when it comes to database engineering and data science applications, which are critical to the digital twin, like the rest of the world. Yeah, I think overall, personally, I don't think we suffer from a lack of skills, but maybe possibly from a lack of standardization, and ensuring that the data that we are attempting to collect is structured across businesses, cities, and even countries. I think definitely digital twins will become, I think, the backbone of the future, and I think it's important that we understand that it is driven to become a new services market, opening up new possibilities. So for a continent, I think we need to embrace that and work towards becoming part of that market and using it to grow economies of countries.
Thank you, Selvan. Dr. Z?
Well, I've got quite a few things running through my head right now. But whereas on the one hand, I'm a bit concerned about, you know, the enthusiasm that a lot of people are, over enthusiasm that a lot of practitioners in Africa are showing towards a digital twin, because even in developed countries, they're still grappling with what's the best use case for these sort of things. I mean, there's nothing wrong with that. The enthusiasm is good, but we just need to temper it with a bit of common sense and logic, and be careful so that we don't end up, wasting the scarce resources that we have into some things that will not deliver value for us and solve the problems, our everyday problems. However, having said that, I'm also encouraged by the fact that sometimes actually the countries or the regions of the world, like Africa, that have not necessarily advanced in one technology can overnight become success stories. I'll give an example. Towards the 80s and 90s, when mobile technology was taking over the world, many parts of Africa were left behind. Nigeria in particular did not have enough even landlines to go around. But all of a sudden, when mobile technology came about, we have the biggest market in Africa. You know what I mean? Because all of a sudden people realize, we're not only going to use mobile technology for this, we can use it for other kind of services, and we more or less bypassed, all those stages of laying copper cables and even fiber optics. We're now using wireless things without having invested in the LAN cable technology that started the internet revolution. We jumped that. You will not see a lot of buildings in Nigeria that have LAN cables, because by the time we were ready, we just moved wireless. So there's a lot of hope for that African countries will learn from, let's say, what's happening in other parts of the world, and they will end up using digital twinning when it's very mature, as long as we don't rush into it right now. But also, like I've said earlier, I think the hope or the vision will be that we will look into our problems and try to use digital twins to solve them, whatever those problems are, whether it's for safety of buildings, whether it's to deliver better healthcare, whether it's to use them like the way we have smart buildings that can be part of your healthcare delivery. I don't know. We need to look at what our pain points. This is the way I like to see it. If I was to make a decision in a business or in a country about a digital twinning strategy, I will use the Pareto principle. What are the 20 aspects of digital? What are 20 maybe areas where we could use digital twin that will give us 80% of value? Maybe some countries might just be, let's just focus on healthcare, have digital twins of all our hospitals, clinics. I don't know. In some cases, it might be housing. In some countries, it might be commercial buildings. But to think that you can just digitally twin every single asset out there, I'm not too sure would be the best way for any country to go, least of all African countries, so in particular. So what it just suggests to me is that a strategy is very important. What is the strategy for implementing digital twin in any particular country or region? And I don't think any country, maybe a few countries can attempt to have one, but maybe having regional or a continental level kind of strategy where we can, like I said, using pilots, we can learn from each other. We can redeploy resources and get people to specialize in different aspects, and then we pull everything together and we can all grow, on the same level. Maybe that's the way to go.
Thank you, Dr. Z. Thank you, Richard.
Yeah, I like that. I really like the idea of sharing knowledge, bringing international experience, seeing as there has been a jumpstart in many of the countries outside of our continent. And bringing that knowledge home to say, well, what can we learn? What are the goods and the bads? And then to contextualize into those pilot studies. And I think on the back of success stories needs to be information sharing and knowledge sharing. And I think that is one of the roles that the joint efforts by academia and by industry are really important to document the successes and to really publish the lessons learned. So that we don't make the same mistake 5 times, but that we can see what works and what doesn't work in our context. Time and time again, we know that things can happen very quickly here at home, and things can escalate in a very positive way to adopt and adapt. And I think that's good. I agree with Selvan. We don't have a skills shortage. We've got everything we need. What we are in need of is a sense of consensus and a way to generally go in the same direction. I'm not saying everything has to happen identically in each of the countries, but I do think that we need to reach a consensus and that we can pool our efforts. I do believe that the efforts that this conference is moving towards of saying, let's all get together around the topic of BIM. Let's find out what works for all of us together. and let's pool our resources and our knowledge and our best ideas is a huge step in the right direction. And I thank all of you for attending. And that is what has encouraged me, is seeing that we're starting on this journey. And as we continue and as we take hands together in this cause, we are going to see great results. Thank you.
Thank you so much, Richard. And on this note, I would like to bring the Digital Twin panel session to a close. I'd like to thank you, Selvan, Machiel, thank you, Dr. Z. Thank you, Richard, for the insightful shares. Of course, we'll have to keep on going, raising the BIM tide across Africa and across the globe. Thank you all so much. Thank you.